Alright. Solutions to review number 1. So on your final exam, there's going to be some transformations. Probably going to give you one basic and then one either reciprocal or absolute value with a twist. So on the grid provided, sketch. I strongly recommend making a list of the transformations. First, double check, is this factored? Yes, it is. Now on your keys that I photocopied for you, sorry, I forgot to put the F of, so make sure you add that, and I'll mention that when I hand this out. Anyways, here's what I see. Remember we said the correct order was expansions, compressions, reflections, and slides. Expansions, compressions, reflections, and slides. What's this 2? This is a vertical. Need some more room, Mr. Dueck. I'll write it over here. Vertical expansion by 2. What's this 1/2 do? Now this 1/2 is next to the x, next to the f of where it belongs, so everything's backwards. Because this 2 over here would be a 1/2 if it was next to the y where it belongs. It's a horizontal expansion by 2. What's this negative do? That's a vertical reflection. What does this negative do? That's a horizontal reflection. 1 left, 2 up. Those are the transformations that are going on here. Let's start with this point. Vertically expand it. Instead of 1 down, it'll be 2 down. Horizontally expand it. Instead of 3 left, it'll be 6 left. Vertically reflect it, 2 up. Horizontally reflect it, 6 right. 1 left, 2 up. It'll end up right there. I would do this point next. Vertically expand it. Instead of -3, -6. Horizontally expand it. Instead of -1 left, -2 left. Vertically reflect it, +6. Horizontally reflect it, +2. 1 left, 2 up. Connect them. I would probably do this point next. Vertically expand it. 0 high becomes and stays 0 high. Horizontally expand it. 4 right. Vertically reflect it. 0 high still stays 0 high. Horizontally reflect it. 4 left. 1 left. 2 up. Yoink. Then I would do this one because it looks like it changes direction right there. Vertically expand it. 2 down. Horizontally expand it. 6 right. Reflect. 2. Reflect. 6 left. 1 left, 2 up. Man, let's do, I have a feeling this one's not going to fit. I'm going to do this one. Vertically expand it, 2 down. Horizontally expand it. Whoop. 8 right. 8 right. Vertically reflect it, 2 up. Horizontally reflect it. There you go. 1 left, 2 up. Yeah, I didn't think it would quite fit, but I'm pretty sure it goes like that. Sorry, it goes off the page. This here, and again, on yours I forgot to put the F of because I was typing in a hurry, but I fixed it on this copy here. Reciprocal function. What did we say? Well, for our reciprocal functions, anywhere plus or minus 1 high was invariant. That was a fancy way for saying that high isn't going to move anywhere. And you'll notice I stopped my graph here because my original graph stops there. Anywhere 0 high becomes a vertical asymptote. It's going to be a vertical asymptote right there. I've now divided this into 1, 2, 3, 4, 5 little sections. Oh, I've already got this section. Let's start walking from an invariant point. How about this one? As I move to the right, my graph's getting further from 0. The reciprocal is going to get closer to 0. Oh, but the highest this gets is -3. The reciprocal of -3 is -1/3. So I'd be looking for a point a little closer than 1/2, a little smaller than -1/2. It's going to curve there. Start on this invariant point. As I move to the left, my original is getting further from 0. Reciprocal is going to get closer to 0. It's going to max at -3. It's going to max at -1/3. And kind of curvy. Here, getting closer to 0 is going to shoot off to infinity. Here, getting closer to 0 but negative, going to shoot off to infinity but negative. That graph there is the reciprocal. Hopefully this is coming back to you. If not, rewatch some of my videos, especially the unit reviews. I like this question. So this is solve. What kind of an equation is this? It's an exponential. How do I know? Because the x is an exponent. How do I solve this? I'm going to take the log of both sides, and I'm not going to take any shortcuts because it's way too easy to make a mistake. I can't move the exponents down yet because if I move the exponent to the front, I'd be saying that it was on the 7, and it's not. What's multiplying two things the same as adding? So my next line, I would go like this. Plus log of 5 to the 3 minus 4x. Now I would carefully move the exponents to the front, remembering for this one that there's going to be brackets when I do so. I'll get 2x log 9 equals log 7 plus 3 minus 4x log 5. Get rid of brackets. I'll get 2x log 9 equals log 7 plus 3 log of 5x. Why did I put an x there? There's no x there, Mr. Dueck. Thank you. Plus 3, you guys are all confused. Sorry about that. Plus 3 log 5 minus 4x log 5. Let's get all my x's to the same side. I'll plus this over to that side there. And apparently write smaller. 2x log 9 plus 4x log 5 equals log 7 plus 3 log 5. How many x's do I have? 2. How many x terms would I prefer? 1. It would be wonderful if there was some kind of grade 9 mathematical operation that I could pull out of my back pocket, as it were. Oh, I can factor out a GCF of an x. And that will leave me with 2x log 9 plus 4. No, Mr. Dueck, it won't leave you with a 2x. Good gosh, am I in a slump or what? I factored out the x. 2, I wish I'd done that on purpose. If I'd done that on purpose, that would be a great fake mistake to get your attention. But I actually did that mistake. Sloppy me. Plus 4 log 5 equals that thing there. I'm running out of room. Final answer. How would I get the x by itself? Why, I would divide this over. X is going to be on the top log 7 plus 3 log 5, all divided by 2 log 9 plus 4 log 5. Type that into my calculator. Let's go to, let's say, 3 decimal places or so. I would, of course, remember to use brackets around the top. Log 7, close bracket, plus 3 log 5, close bracket, close off the top, divided by bracket. 2 log 9, close off the log, plus 4 log 5, close off the log, close off the bracket, enter. I get 0.6254. 0.6254. Now, let's just double check to see if I'm right. There was a way you could check your answer. I won't accept this for work, but you can check your answer, and that was to clear any equations, to graph the left side, 9 to the power of bracket 2x. To graph the right side, 7 times 5 to the power of bracket 3 minus 4x. Pick a view window. I usually go zoom standard. There's the first graph. I can barely see it, but it's there. There's the second graph. I can barely see it, but it's there. Where are these two equal? Where they cross? Second function, calculate. Intersection. First curve, second curve. Yes. And hopefully I get 0.6257. I do get 0.625378. So I know I'm right. Woohoo! Word problem. Half-life. We said the equation that you're going to use looks like this. Final amount equals the initial amount times the growth rate to the power of the total time divided by the period. Now, for a half-life question, we know that the growth rate is a half. That's what half-life means. Oh, the initial amount is 400. The final amount is 50. The total time is 16 days. And they're asking me to find the half-life, which is the period. If I plug everything in, I'm going to get 50 equals 400.5 to the 16 over p. I cannot go, oh, 400 times 0.5. Why, that's a 200. No, that would be violating BEDMAS because there's exponents. I have to deal with those first. What I can do is go divide by 400, divide by 400, and I get 50 divided by 400, which is 0.125. 0.1, come on, decimal. 0.125 equals 0.5 to the 16 over p. Where is the p sitting? In an exponent. Oh, take the log of both sides. How much more room do I have? A little bit more. Now what? Move the exponent to the front, and I yelled at you, write a proper fraction, not a slanty small midget one, a great big one, so you can clearly see what's on the top and what's on the bottom. Because now I can say, oh, hey, this is straight cross multiplying. P is going to end up being 16 log of 0.5 divided by the log of 0.125. And my pen's not working really well. 16. This might even work out evenly. That'd be a fluke. 5.33. That's the half-life. 5.33 what? Well, it depends on what my original unit of time was. What was my original unit of time? Days. So there you have it. Review number 1. Save. All fair game for your final exam.